Hey guys, welcome back. Today we're doing 1.5 parametric relations and inverses. Okay, that's really all we're doing. Parametric relations and some parameters on stuff, and then inverse of those and determining if something's a function. Okay, so if we define a function parametrically, and so you're gonna get the set of ordered pairs, your x equals and your y equals right here, okay? And then you're gonna get the parameter of t, and so it's gonna give you a number. In this case, the example that we're gonna do, our t is -3. Guys, this is super simple. To find our x value, our t is -3, so we're gonna say -3 plus 1, -3 plus 1 is -2, so there's our x value. For our y, we have -3 squared plus 2 times -3. Okay, so -3 squared is 9. 2 times -3 is -6, so that would be 3. So there's our y value. And so that parameter, that point is -2, 3. -2, 3. Okay, that's all I got. There's your extra y value. And so like if we plotted those or whatever, it would go through those 2 points. Okie dokie, let's talk about inverses. Okay, so if we have the ordered pair AB, it is a relation if and only if the ordered pair BA is the inverse relation. So inverse is just opposite. So you switch x and y value. X and y values. Okay. So if we have this parabola, our x is -1, our y is 1. Okay, here 1, 1, x and y. Okay, so here if we switch those, that would be 1 and -1, which would be right here. So this point, the inverse is this point. Obviously 1, 1 switched is still 1, 1. Okay, and so this parabola and this parabola are inverses. So this is f of x, and this would be denoted as f, and it's like to the -1 power. That's how you write your inverse, okay? And so if you look at the inverse of a relation, B fails the vertical line test, so this is not a function, and you can tell that, I'm gonna say not a function. Okay, and you can determine if your inverse is going to be a function by doing the horizontal line test on your actual function. Okay, so if you look at the red line, that's like the horizontal. So to determine if a function is, or a relation is a function, you do the vertical line test. Okay, to determine if its inverse is a function, you can do the horizontal line test. Okay, and because it doesn't pass the horizontal line test, when you do the opposite, it wouldn't pass. Okay, so let me erase all this fun stuff. Okay, and so we have horizontal line test. It tells you, if you do the horizontal line test of a function, it tells you if your inverse of that function is also a function, okay? And so an inverse of a relation is a function if and only if each horizontal line intersects the graph at one point, okay? And so if you have a relation, let's look at A, we'll say 1, 2, 3, and 4. If we look at 1, we have vertical line test, okay? So this, yes, f of x, yes, is a function. Okay, and so to determine, without actually finding the inverse, to determine if the inverse is a function, we do the horizontal line test. And so if you look, I'm going to actually draw a line and move it up and down. Okay, and so there's like our pencil. Those are asymptotes. I know they kind of look like but they're just going to keep getting closer and closer to that x-axis, so it doesn't close. So the inverse, yes, is also a function. Okay, and let's look at, whoa, did you see that? Can I do, I'm gonna erase that. Okay, so if we have number 2, we have, if we look and we determine if f of 1 is an in function, well, no, f of x, that relation of f of x is not a function. So f of x, this original function is no. Sorry, the original relation is not a function. Okay. And then if we look at the inverse, so f of -1 of x would be this way, okay? And if you look, those are going to be your horizontal asymptotes, and so those don't cross, that's another asymptote. Okay, so, but the inverse of this one is a function. So the inverse is yes function. Okay, and so I'm going to stop drawing my line and we'll just kind of look. So this, if you look, your f of x is no, and the inverse of f of x is also a no. Okay, vertical and horizontal are a no-go. And then if we look at this one, your horizontal line, so your f of x is a yes. And then if we look at the horizontal line, will tell us about our inverse. Okay, so look right here, here, and here. So our inverse is a no. Okay, and so a function whose inverse is a function that has a graph that passes the horizontal and vertical line test, like this one, like number 1. Okay, this is the only one that the function and the inverse of that function, they were both, I keep saying function twice. Okay, so we have this relation, okay, and if the relation is a function and the inverse of that relation is a function, then that means that they are 1-to-1. So that means for every x value, there's only one y value. Okay, x is paired with one unique y, and every y is paired with their unique x. Okay, and so this is the only one that is 1-to-1 because they pass the both vertical and horizontal line test. Okay, so now let's practice finding the equation for the inverse. And so to find the equation of the inverse, if we have our function y equals x squared minus 1, and so this is the same thing as f of x is equal to x squared minus 1. Okay, and so to find the inverse of that, we switch our x and y values. And so I do like to write, I go from here to here. So like if you're presented with f of x equals x squared minus 1, change it to y equals x squared minus 1. Okay, first step is to switch x and y's. And then your second step is to solve for y. Algebraically, however you need to do that. Okay, so if we had y equals x squared minus 1, your y goes here, your x goes here. Okay, and that's where you see here. So now we need to solve for this y, and we add 1, so we get x plus 1 is equal to y squared. Solve for still just this y, so break it up with the square root. So we get plus or minus the square root of x plus 1 equals y. And so we need to rewrite this back into the inverse form. So this would be your f of -1 to the x power. F to the -1 of x is equal to plus or minus the square root of x plus 1. Okay, so this is your inverse. Okay, and then that is your original function. Okay, and so let's do it algebraically without some help. And then it asks what's the domain of the inverse. So our first step is to switch x and y and then solve for y. So this could be represented as f of x is equal to 2x plus 8. So we switch our x and y. So that would be, this goes there, that goes there. So we have x equals 2y plus 8. Okay, solve for y, minus 8, so we have x minus 8 is equal to 2y. Okay, divide by 2, cancel, so we get y is equal to x minus 8 over 2. You can leave it like that, or you can do y equals x over 2 minus 4. Okay. And then to write that, so that'd be f to the -1 of x is equal to x minus 8 over 2. Okay, so this is your inverse. And then what is the domain of the inverse? And so x is in the numerator, not the denominator. We don't have a square root, so that tells me that it's all real numbers. So that would be from negative infinity to positive infinity. Okay? Now let's talk about the inverse reflection principle. So if something is a reflection, so if we have points A, B, and B, A in the coordinate plane are symmetric with the line y equals x. Okay, so that's that linear line, y equals x, starts at the origin, up one, over one, up one, over one. And so that's your OG parent function of y equals x. So the points A, B, and BA are reflections of each other across that line. And so if we have a graph of the function y equals f of x is shown, so we're gonna sketch a graph of y equals the inverse, okay? And so is it a 1-to-1? And so if it is to graph this, sorry, it's a reflection, so we start here at 0, 0, we go up 1, over 1, up 1, over 1, up 1, over 1. And the same, down 1 to the left 1, down 1 to the left 1. Okay, and so this right here would be the reflection line. So it's a mirror image, and this is flipped over here, and that is demonstrated a little bit better. Okay, so we have the graph of f, and so we drew the red, that's our mirror y equals x, and then we flip it, okay? And so if you notice, this is symmetric, right? This is the same, that crosses there, 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 okay? And so the graph of the inverse is the black, and it's just a reflection of y equals x. Okay, and then the inverse composition rule is, so this is the composition of functions. And so if they are inverses, if you do f of g and g of f, your result in both of those is an x. Okay, and so that's right here. So f of g of x equals x for every x in the domain of g, and g of f of x is equal to x for every domain of f. So we're going to do the composition of both of these, and if it results in x for both, then they are inverse of each other. Okay, so let's do f of g of x. So f of g of x. We start on the inside, which is g of x, which is x minus 4 over 8. So we're going to plug that into f. So that would be 8 times x minus 4 over 8. And then plus 4. Okay, so let's simplify that. 8's cancel, so we have just x minus 4 plus 4. X minus 4 plus 4s, those cancel, so we get x. Okay, and then if we do g of f of x, okay, we start with f of x on the inside, which is 8x plus 4, so we're going to say 8x plus 4. And that's going to go into g's x value. So we have g, no, I'm not going to write g, I'm going to say that 8x plus 4 is going to go there. And so 8x plus 4 minus 4 over 8. Okay, 4 minus 4 cancels, so we have 8x over 8. 8 over 8 simplifies to just be x. Okay, so we got x, we got x. So these two lines, f of x and g of x, these are actually inverses of each other. They're complete opposites. Okay, and that's it. Find some questions. Let me know if you have any issues, comments, questions, or concerns. There you go.